A very good morning, class. In the continuation of this chapter, coordination chemistry. Today I'm here with the lecture number 3. So let's start with this. This is a recapitulation of the previous video. Whatever I have explained, all the important terms over there, so that it is here also. Like I have explained you that there is a coordination sphere, which will be denoted by this big parenthesis, yes, and inside the whatever the substance present in the inside this parenthesis, that will be called coordination entity. Yes, there will be a metal that is also known as central atom, and other than the central atom, whatever the elements or compounds or groups are there, that will be considered as ligands, and the total number of ligands will give you the coordination number for the monodentate ligand. But if it is didentate or bidentate, tridentate, something like that, the number of ligands multiplied by its denticity will give you the coordination number. Yes, and the ion which is present outside this big bracket, that will be called counter ion, or you can say that the free ions. That means this must be an ion. It cannot be positive. It cannot be any neutral one. Okay. So this will be considered as the type of substance. This type of complex is known as cation complex, cationic complex. Okay. So here it will be counter ion. When it is undergoing or when it dissolves in water, this will give you the big complex cation and an ion like this. Okay. So due to this Cl minus, whatever the Cl minus test it will be there, that will be given by this compound. Okay. Okay, next is IUPAC nomenclature of coordination compound. So how it is, like, first we are supposed to name the cation before anion. Yes. Then name the ligands in alphabetical order, and ligands with have a numerical prefix, like it is hexa, tetra, penta, whatever the number is there. And after that, after the ligands, central metal atom ion is named. Neutral ligand are given as the same name as uncoordinated molecule, like amine, aqua, carbonyl, like this. And they will also be like the ligands are named alphabetically, ignoring the prefixes bistress. We don't have to consider that bistress. That the name of the complex with whatever the word, whatever the letter it starts, that we have to keep in your mind. Anionic ligands are given names with which ends with the letter O, like oxalato, glycinato, carbonato, sulfato. Some ends with this ido also. Okay, like chlorido, cyanido, something like that. When the coordination entity is an anion, the name of the metal is altered to end in ate. Like if there is an anionic complex, if it is this is cationic complex, so here it will be named as like cobalt. But if it will be anionic complex, then it will be cobaltate, 8, and it will end with the 8. So that is the like recapitulation of the previous video. So let's move forward for the next thing. And that today we are going to do that isomerism in coordination compound, which is also going to be a very important topic. And 1 mark question, like coordination number is of 3 or 4 marks. So 1 question from this topic is 100% sure. 1 question will be there. So let's start with this. Isomerism, like 2 or more substances having the same molecular formula but different structural or spatial arrangement. That means whatever the space arrangement, okay, are called isomers. And this phenomenon is called isomerism. We all know this isomerism. They must have the same molecular formula, but their arrangement, their structure will be different. Yes, that is called isomers and isomerism. So as like other compounds, it is also having 2 like types. So we will do that. Isomerism is derived from a word, Greek word, that is iso and meros. Iso means equal, meros means parts. So equal parts. It is of two types, structural and stereo or space isomerism, that we have all also done in organic compound also. Yes, structural, and then stereo and space isomerism. So now we will first complete this structural, and then we'll go for the stereo isomerism. So in this case, in the in the organic compound, we have done that structural isomerism is of 6 types, isn't it? That the first was position, then chain, then functional, then metamerism, then tautomerism. But that will not be there. Exactly different. Structural isomerism will be of 4 types, and the types are ionization for the coordination compound. Okay, so structural isomerism is of 4 types. First is ionization isomers, second is coordination isomers, third is linkage, and fourth is hydrate isomerism. So these are the 4 types only. And stereo as it is, जैसे उसमें था वैसे same, geometrical and optical. Okay, so let's start one by one. First we will complete the structural isomerism. As I told you, the structural isomerism, the type of isomerism arises due to difference in the structure of coordination compound. That is called structural isomerism, and again it is going to be of following types. So that is, first is ionization, second is hydration or solvate, third is linkage, and fourth is coordination isomerism. Okay, so as this was given in the flowchart previous slide, so that the same is it is. So ionization isomers, let's start with this. As the name suggests, ionization, that means whenever it undergoes ionization, it will give you the different ions. Okay, that means such compound which is having same molecular formula, but whenever it undergoes ionization, that means whenever it is going to be separated in ions, it will give you the different ions. Okay, so compound which give different ions in the solution, although they have the same composition, are called ionization isomers. As for example, we'll do, just wait. This type of isomerism occurs when counter ion of the complex, this is important part, so let me mark over here, when counter ion of the complex is also a potential ligand. It means that like whatever that the counter ion, if we are going to change, that means it must have the negative charge, same charge. Okay, same not number, I'm saying same charge. That means if it is positive, if it is negative, so it that the complex that exchange will be with the same type of ligand. Yes, negative ligand. Hence it can also displace the ligand which can then become the counter ion. So ये उसी को displace कर सकता है, उसी ligand को displace कर सकता है जो counter ion बन सके. Did you get that what I'm saying? So that means it will have the same charges. Like if like a negative charge is there. So let's do with the example. You will better understand this. So example is like this. Here it is having 2 type of ligand. One is NH3 and here one is OH. So out of this one is neutral and this one is negative. Yes, this one is negative. So counter ion, that means always it is negative, isn't it? So what I will do, this, it will go inside, this will go inside and this will come outside. Okay. One thing you have to keep in your mind that the coordination number shouldn't be changed. Coordination number change nahi hona chahiye. Here it is mistaken, sorry. That should be OH. One OH will go only, not another one. Okay. I will correct it in the PDF, don't worry, but let me mark over here. This is one OH will go inside and one OH will remain will go outside and one OH will remain inside. Why? Because if I am here, no need to balance the charge. Like it is -2, so it doesn't mean that we have to put the -2 outside. Did you get that what I'm saying? There will be only if it is negative. So negative ion ही बाहर आएगा. That means which has the capability to form the counter ion. Like if I want to send this NH3 outside, will it work as a counter ion? It is a neutral ligand. It doesn't have any charge, isn't it? So this cannot work as a counter ion. So that means we cannot exchange between NH3 and SO4. Yes, it is clear. And another thing what I have told you, that the coordination number should not be changed. Coordination number change nahi hona chahiye. So what is the coordination number over here? This is 4 to 6. Yes. So what we will do? One SO4 is going to come inside. अगर एक सिर्फ एक SO4 को अंदर लेके आओगे और दोनों के दोनों OH बाहर चले जाएंगे. So what is the coordination number? 4 and 1. This is 5, isn't it? The coordination number changed. So it should not be. Coordination number will remain same. So that means in this way, only one OH will go outside, one OH will remain inside. So here it is one ligand OH, another ligand, and 4 ligands. So 2, 4, 6. Coordination number has not changed. Yes, I hope it is clear. Let's do another example. In this case, you can see that 2Br, 2Cl are there. Coordination number, if it can, like, I can write, like, what will happen if, can you write like this, wait. So I'm just asking, can I write like this, that one Cl is exchanged with the one Br? Yes, one Br went inside and one Cl came outside. So can I write like this? There is no problem at all. If you'll check that oxidation number of platinum is whatever it was here, it is same here. The coordination number is also same, 4 to 6. Yes, everything is same, nothing changed. But two different types of counter ion will not work. That will not give you the stable compound. So that's why what I will do, both bromine will be exchanged with the both chlorine. Did you get that? So two different types of coordination, that counter ion should not be there, because it is not giving a stable compound. Ye unstable ho jata hai. So that's why we will not make like this. Yes, I hope it is clear. In the next case, again, what exchange? NH3 with the NH3 we cannot exchange because it is neutral ligand. So NO3 is having -1, nitrito. So one NO3 will go outside and SO4 will come inside. So that can be done. Yes. Now, sometime question will be asked that what is the way by which you can prove that they are ionization isomer? Okay. How can you prove that they are the ionization isomer? So the question will be there, like one question is given like this. Like two type of question. One question will be asked like this thing, that this and this prove that they are ionization isomers. So it is not like one in this bromine is outside, in this chlorine is outside. So they are having same molecular mass, same molecular formula, but counter ion are different. So they are ionization isomers. You are not supposed to say like this, as you have done in the organic chemistry, that the chemical test you are giving for identification, isn't it? So similarly here also you will do a chemical test. It should be a laboratory test, that you have to add some chemical to identify that it is are they ionization isomer or not. So since they have same molecular formula, I have given it that two compounds I have given, both are having same molecular formula, and chlorine and bromine are there, can be the counter ion. So prove that how they are ionization isomers. So what you will do, in both the beaker you will add AgNO3. Yes, in this also, in this also. So in this case the bromine is there, so it will form AgBr precipitate. Yes, and AgBr, we know that what color it is yellow color. So the one which is giving yellow color, that means the bromine is there as a counter ion. And the one which is giving AgCl, that means white PPT, that means it is in this compound the chlorine is as a counter ion, and hence it is proved that they are have ionization isomers, because already we know that they have same compound, they are having same molecular formula. So only we have to say prove that counter ion are different. So that's it. Like add the AgNO3. Similarly, suitable test we have to do. Add some substance, same substance in both the case, and find the differences. That's it. So this type of question can be asked from this topic. Okay, now this is again the interchange of ligands and anion. How to draw the structure? This is octahedral because 6 ligands are there. How it is octahedral, that I will explain later on in the hybridization. Finding hybridization for the coordination compound, there we will do. Right now, let's this octahedral. So in the octahedral compound, this is one plane, एक plane, and this one is outside the these are the 4. Ye 4, 1, 2, 3, 4. These are in the same plane, and this one is above the plane, one is below the plane. So that is, in this case, SO4 is there. So what I have to do, if SO4 is going inside, that means which one is the negative ligand over here? Bromine only. So bromine will come outside. You don't have to keep it think about it that it is having -2. Earlier the cation was having +2 charge, but in this case the cation is having +1 charge. So charge is different. It's nowhere a matter of concern. हमें वो नहीं check करना है. यहाँ पे क्या करना है, बस हमें इस चीज का ध्यान रखना है that coordination number should not be changed, and that whatever exchange is there, so the ligand should have the capability to act as a counter ion. That's it. Okay. So their physical properties will be completely different because this is SO4, this is Br, so completely different. Add how you will prove that they are the isomers, ionization isomers. So add BaCl2 in both the case. BaCl2. Yes. So this BaSO4, this one will give you white precipitate and there is no change. So you can say that they are having different physical properties. Other examples are there. In this chlorine and bromine, there is an exchange between chlorine and bromine. You can see that? Yes. Now the next example is solvate or hydration isomerism. For this isomerism, it is very easy to learn that in that water must be there as a ligand. The thing to learn, the water must be there as a ligand, and counter ion, at least more than one counter ion should be there. Did you get that? More than one. I'm not saying more than one type of counter ion. More than one counter ion should be there, and water should be there as a ligand. Then only this isomerism is possible. So compound which have the same composition but different in the number of solvent molecules present at ligand, that is in the coordination sphere, and as free solvent molecules present outside coordination sphere in the crystal lattice are known as solvate isomers. So we can see that in this, there is this is OH2 I have written, but it is quite clear that it is H2O. Okay. So water is there as a ligand and more than one counter ion is there. So what I will do, one chlorine will go inside, one water will come outside. Yes, can I do like this? Now you will say that here two type of counter ion. No, here also one counter ion only. See, this one is not the counter ion. ये H2O जो होगा, that will work as a water of crystallization. Did you get that? It will act as a water of crystallization. So water molecule वहाँ पे होगा. It is nowhere going to change the composition and all. Now, this what next? One more Cl can go inside because एक के जाने के बाद भी there will be negative ligand. Yes. So one more Cl will go inside, and to maintain the coordination number, one H2O has to come outside. So this is the structure. Yes. Two chlorine went inside, one chlorine is outside. Now, is it possible, although H2O molecules are more, so H2O molecule come outside, but क्या और chlorine को मैं अंदर भेज सकती हूँ? No, because if one more chlorine will go inside, there will be no counter ion. So completely change हो जाएगा. The compound, the nature of the complex will be changed from the cationic complex to the neutral complex. So that's why it won't happen. I hope it is clear. Yes. So the name of this compound will be like hexa aqua chromium 3 chloride. Here it will be penta aqua chloro chromium 3 chloride. What about this water? So you have to write monohydrated as a prefix. Okay, monohydrated penta aqua chloro chromium 3 chloride. Here it will be dihydrated. Yes, dihydrated tetra aqua chloro chromium 3 chloride. I hope it is clear. The two things important you have to learn that. Let me write here. So here I have written two important points, that it is H2O should be there as a ligand, and next point, more than one counterion should be there. तभी solvate possible होगा, otherwise solvate or hydration isomerism is not possible. For example, this is a animation problem, so let it be. Now another thing, example, here it is, we can see that the color of this, when only chlorine is there, all the water molecules are inside, then it is violet color. 1H2, if it comes monohydrated, it will be blue-green, and if dihydrated, it will be dark green. So some type of questions like this, it will be asked. So what you have to do, जितना ज़्यादा water molecule उसके अंदर रहेगा, उतना ही color वो dark होगा. If less number of water molecules, it will go towards the white color, colorless. Did you get that? Yes. So let's move to next, linkage isomerism. Linkage isomerism is also very easy to learn. It will be given by only 4 ligands. Yes, and that is called ambidentate ligand. If ambidentate ligand are present over there, then that compound will show the linkage isomers, otherwise not at all. So isomerism of this type occurs in compound containing ambidentate ligand. This is important, as I told you. That is, when more than one atom in a unidentate ligand may function as a donor. I hope it is clear, the definition part. Okay. Example, we have 4 ambidentate. NO2 can also be attached with the O, and it will be called nitrito O. This is nitrito N. SCN, that can be attached with the N also. This is thiocyanato. This is isothiocyanato. This is Cn minus cynato, or this is NC minus isocyanato. So these are the 3 important one which will be used as a linkage isomers. One more is there, I will tell you. So let's see, this is like simple, nothing to do, just SCN ki jagah pe we will do this NCS, that's it. And the name will be changed. Name, what is the name for this? Penta aqua thiocyanato chromium 3. This is -1, okay? Chromium 3 ion. And here it will be penta aqua isothiocyanato chromium 3 ion. Yes. Similarly, in this case, it is, and here it is NO2. This is NO2. And here I have changed this as a ligand, ONO. That's it. Yes. So the name of this is nitrito N, and here the name is nitrito O. Nothing changed. This PY is pyridine. It is also a neutral ligand. Okay. PY means pyridine. So what will be the name for this? This is diamine dinitrito N bispyridine cobalt 3 nitrate. And this will be nitrito O ho jayega. Yes, I hope it is clear. So next is like this one we have already done. This one is known as nitrito N because it is, the metal is attached with the N. So this will be nitrito N, and here the metal is attached with the oxygen, so it will be nitrito O. Yes. Here the metal is attached with the Cn, so this is cyno, and here the metal is attached with N, so isocyano. Similarly, this is S, thiocyanato, and this is N, so isothiocyanato. These are the 3 important ones. Now this is, you can see that the metal is attached with the N, so what will be named? Jo bhi named, you will say 1, 2, 3, 4, 5. Pentaamine and this one is nitrito N, cobalt 3. Yes, this will be pentaamine nitrito O, cobalt 3. Yes, so this is called linkage isomers. That's it, you have to draw. Isothiocinato, cyanate, like this. And the fourth, which I have told you, this is cyanato and isocinato. Now, you will say that in some case it is like this is cyanate here and here. Cn minus को भी हम cyanato कहते हैं. This is also named as cyanato. So in this case, if both the compound are there, both the ligand are there, the Cn minus is also there and this NCO is also there, then this will be named only as a cyanone. We are not supposed to mention it as a cyanido or cyanato. It will be mentioned as a cyano only. Got it? What I'm saying? I'm saying like if Cn minus and NCO both are there as a ligand in the compound, then this will not be named as a cyanato. It will be mentioned as cyano only. Yes, and this NCO will be cyanato. Similarly, if it is attached with the O, then it will be called isocyanato. Yes. So these are the four, which is, this one is rare. Matlab like 10% chances for this. Yes. So we will not, these are the 3-1 which I have told you, that is the important one. So you have to be careful with this. This is NCS and SCN, as I told you. Okay, next is linkage isomers. You can see that there are like, I got a picture, good picture, so that's why I have added. Here nitro isomers is yellowish in color, but this is nitrito. If I'm saying this is like orange in color. So, okay, here oxygens attached, here nitrogens attached, that is. Okay, now coordination isomers, and this is the last topic for the structural isomers. Okay, so coordination isomers is again going to be very easy. What to do, how to identify. If both the cation and anion complex are complex, then only the coordination isomers will be possible. What I said, if both the cation and anion are like complex, then only this is possible, otherwise not possible. So in this case, what we will do, simple, this type of isomerism is possible when both the positive and the negative ions of a salt are complex. Yes, and two isomers differ in the distribution of ligands in the cation positive and the anion. Ab yahan pe let me show you some example like this. Like cobalt NH3 whole 6 hexaamine cobalt and hexacyanatochromate. So isomers will be like this. One thing if you have to keep in your mind that we are not supposed to change the ligand. हम ligands को change नहीं करेंगे. जो पॉजिटिव स्फीयर में लिगेंड है वो पॉजिटिव में ही रहेगा, जो नेगेटिव में है वो नेगेटिव में ही रहेगा. ओनली द metal will be changed. What is the reason behind it? I will tell you. Just the important point I have told you, that only the metal will exchange, not the ligands. So in that positive sphere, cation sphere, NH3 was a ligand, so it will remain like this. Instead of cobalt, the chromium will come and this cobalt will go in this. So iska naam kya tha? Hexaamine cobalt 3, hexacyanatochromate 3. But in this case, it will be hexaamine chromium 3 and hexacyanatocobaltate 3. Did you get that? The one very important thing, that only the metal will exchange, not the ligands. Yes. Another example is also there, like chromium and cobalt I have exchanged. And this type of another example, another important part is that this type of isomerism is shown by such metals which show the same oxidation number. Okay, that is also important point. First, both the cation and anion should be complex, and second, the metal should show the same coordination number. So like, and this is the most common compound, chromium and copper ke compounds that are the most common compounds for the coordination isomers. Okay, as I told you that I was telling you that why not this ligands will change. What will happen if I will change the ligand? Let me show you. This is the third example over here. Okay, let me show you like I have changed this ligands. Then let me see the consequences. What will be the consequences? Okay. As I told you that this is the +3 oxidation state, like cobalt. So this is also my like it is agar cation, this is in +3. They are going to have same oxidation number. So let me assume that this is having plus, yes, and this is having negative. If it is going to, so this will have if it splits in ions, then what will have? This is CO, Cn 6, and it will have minus charge. Yes, minus, suppose kar leti hu that minus. So now find the oxidation number of cobalt. What you will get? You will get cobalt oxidation number is +7, isn't it? And similarly in this case, it will have positive charge when it will dissolve in water, isn't it? So chromium will have +1 charge. The oxidation number is changed. Okay, चलो कहो कि अगर मैं यहाँ पे -3 रख देती हूँ, so that कि we will get the chromium cobalt here. So if I will -3 करती हूँ यहाँ पे, so cobalt will have -9 oxidation number, and in this case the chromium will have +3 oxidation state. The oxidation number of cobalt is going to change drastically, and that is not possible that cobalt and chromium will show any other oxidation number than this 3. I hope it is clear. So that's why you have to keep in your mind that only the metal will be changed, not the ligand. That is a very, very much important point for this. Yes. So that was the last topic for this structural isomerism. Now the next topic is space isomerism, that means a stereo isomerism, that we will do in our next video. So by the time, watch the video properly and practice for naming and practice for finding the isomerism and how to write the isomers. Yes. So till then, thank you class.